Hey everybody, welcome to my physical world. Yes, some of you come to this channel for Blender tutorials and Microsoft Flight Simulator scenery tutorials, but I just have to let you know this is a full physical science channel, and I am a geospatial scientist, a cartographer. I use geographic information systems and Earth observation satellites, and I do a lot of analysis on natural disasters and agricultural type of stuff for crop health and all that kind of stuff. And I just want to show you guys some analysis that I've finally been able to work on. And we are looking at Andover, Kansas, and this satellite image happens to be Sentinel, Sentinel 2 Alpha and 2 Bravo, two satellites, two Earth observation satellites put out by the European Space Agency that work in tandem to assess different aspects of the Earth. Okay? I primarily, probably 90% of the time, I use Landsat 8 and 9, which is basically the same type of a platform, except the Landsat program's been in orbit for a little over 50 years now, and Sentinel is approaching 2 decades, maybe a little less than that. But both these platforms are extremely useful for analyzing natural disaster. Now, let me talk about Earth observation satellites for a second. Earth observation satellites, both Landsat and Sentinel, use different bands for small swaths of the electromagnetic spectrum. Okay, light waves, basically. All right, so you got the gamma rays and X-rays that are really, really small wavelengths all the way through the infrared, which are very long wavelengths, okay, and microwaves and radio waves and all that kind of stuff. But these Earth observation satellites look at a swath of that electromagnetic spectrum, usually from the blue lights through the shortwave and shortwave radiation. Okay, so each band takes a little slice of that electromagnetic spectrum. Landsat has bands 1 through, actually they have bands 1 through 11. And Sentinel also has bands 1 through 11, actually 1 through 12. Okay. And each band dictates a different reflectivity. Okay, so it measures the light hitting the Earth and bouncing off of it. All right, so for instance, band 1 is useful for looking at coastal aerosols. Band 2 is blue light. Band 3 is green light. Band 4 is red light. And then you start getting into the infrared bands, which are 5 through 12. Okay, Sentinel has 3 bands that are shortwave radiation, 10 through 12, and then near infrared is band 8 and band 8A. Okay, and then mid to long wave. Near infrared would be your 5, 6, and 7. Okay, Landsat is almost comparable Bands 1, 2, 3, and 4 are pretty much exactly the same with some small variations in wavelength. And then 5 and 6 are your near and mid IR, and then above that is your shortwave infrared. All right, so enough teaching on that. So here we are. We're looking at Sentinel, 2 Alpha and 2 Bravo. This image was acquired April 24th, 2022. And this is the area that I want you to concentrate on right here. All right. Now I'm going to bring up the May 9th image. Okay. It's a little lighter because this one's been corrected for top of the atmosphere reflective. The one from April was not. I have not corrected it yet. All right. I have algorithms. I work, like I said, I work with Landsat most of the time, 90% of the time. And I have all my programs and algorithms written to do the corrections automatically for me. But Sentinel, I don't, so I have to do it by hand. Anyway, I did it for May 9th. So the image itself looks a little lighter, but if we turn May 9th off, I want you to concentrate on this area right here, okay? So when I turn on May 9th, you'll notice something. Something shows up on the ground between these two. If you look right here, watch this right here, okay? Turn it off. Now turn it back on. You kind of see a ghost image through here, okay? Because since the satellite is getting reflectivity off of the ground, any changes in the ground are going to affect that reflectivity, all right? So as our tornado, not our tornado, I don't live here anymore, but as the tornado was on the ground, it was throwing all of the debris from what it hit and lays it on the ground, all right? And that affects the reflectivity of normal objects on the ground, all right? So if I turn this off, it's pretty uniform in contrast in this area. This was before the tornado. Okay, this is what it looks like after the tornado. You can kind of see a ghost fuzzy image of things that are affecting the ground reflection to the satellite. Okay, so let's move up through in this area. Okay, turn it off, go to May 24th. Looks pretty uniform through here. But if I turn May 9th on, I'm seeing some fuzziness up through this area as well, meaning that there's tree limbs, there's 2x4s, there's steel siding, there's all types of stuff that's affecting the ground reflection to the satellite. Okay? Now, another tool that we can use, this is ArcGIS Pro, which is the most advanced geographic information system on the planet. And one of those memes that we see on Facebook changed my mind. This is the most advanced GIS out there. QGIS, which is open source and free, is great. It does a good job. I use it as well, but it cannot compare to ArcGIS Pro. I mean, it just won't. You won't change my mind. Anyway, you guys that use QGIS all the time, you know, more power to you. You're doing a great job. It does what you want, but I prefer ArcGIS Pro. All right, so anyway, we're looking at this change detection. I digress. I don't want to get into a debate. We're concentrating. We're working together. All right, so in In ArcGIS Pro, let's go to the Appearance tab, and I'm going to hit the swipe, and I got to make sure that May 9th is on. And I'm going to swipe over. So instead of turning my layers on and off, I can swipe back and forth to see any visual changes in the reflectivity, even though 24th I have not corrected for top of the atmosphere. Okay, but I know what I'm looking at. I've done this for decades. All right, but I'm seeing those subtle changes on the ground that I can start to do my work. Okay, so like right here, I'm seeing some ground torn up. Okay, I'm seeing some litter on the ground in this area right here. All right, there's changes in reflectivity. There's actually possibility of major damage or of building. Down here by the YMCA, which it went across here and back over here. And then this neighborhood right here is really affected. Okay, I'm seeing that ground litter, and then I can see my swaths coming through this area here. Swipe tool, I can go up and down, but I do better going left and right. Okay, like that. All right, so the next step would be to study that change and create a damage path, which I have digitized here. I have followed any subtleties that I've seen in the pattern of the ground. Now, it got a little bit more obscure up through this area, so I just stopped right here. But I can be pretty certain that in this area, inside this green polygon here that I made, that was the actual swath of the tornado. Now there might be some residual damage. I can actually see some residual damage out here. But with ground proofing, that means people out there with drones and aerial photography and stuff, you can fine tune this with later analysis. Matter of fact, it's probably over this area right here now looks to me affected by the tornado. And this area like here, so I'd go in and adjust that. All right. But what would be the next step in your analysis? Okay, I worked for this county back in the 1990s, and we were hit by a tornado back then, and I didn't have the ability to call up Landsat imagery as fast as we can today. I can do that any day, any minute, any second of the day. I can call up any imagery if the satellite had gone over. Okay? If not, I have to wait until it does go over. Back in the 90s, we didn't have that luxury because it wasn't available for free on the internet yet. Okay, but now both Landsat and Sentinel are free to access through the USGS's portal. So I can get it anytime that I want. So matter of fact, I downloaded this May 9th one just this morning because I was waiting for it. A flyover. I was hoping to get Landsat because I have more analytical tools for Landsat than I do for Sentinel. But Landsat, its repeat day is one satellite repeats itself at the same location every 16 days. With both Landsat 8 and 9 working in tandem, they're on opposite sides of the globe. They repeat every 8 days. Now Sentinel has a 12-day repeat, and working in tandem it has a 6-day repeat. All right, so you're at the mercy of the clouds. All right, Landsat had great image prior to this tornado, but every day of its repeat after the tornado, it was too much cloud cover for me to use for analysis. So I got lucky with Sentinel. So Sentinel's return was May 9th. The May 3rd, it was cloudy, so I wasn't able to use that image. You guys following me? Okay. So you have Landsat and you have Sentinel, and you can use them. You can actually use them all together and work with them. Even though the resolutions are a little different, you can still use Landsat and Sentinel in tandem and do some analysis. You just have to be aware of the differences in resolution. Sentinel has 20-meter resolution. It does have some bands that does 10-meter resolution, which is 32 feet for those that don't speak metric. And Landsat is 30 meters with some bands that do 15 meters. But one thing that you can do with Landsat that you cannot do with Sentinel is thermal stuff. Sentinel has some satellites that aren't 2 Alpha and 2B that does thermal, but that's a totally different satellite platform. Okay, but Landsat has thermal imaging built into Landsat 8 and 9. Actually, it had it with Landsat 3, 5, 3, 4, 5, 7. Okay. Anyway, I digress. All right, so what do we do next is, like I said, in 1999 when we got hit by a tornado just south of Wichita, this is Wichita here, I was able to use ground proofing, people out there taking photographs and aerial photographs and sending them to me in the office. I was able to fine tune my swath, all right, because I didn't have Landsat back then. I had Landsat, but you had to order it and get it in the mail on a tape. How archaic is that? All right. Nowadays, I can get instant data. Okay. If the satellite had gone over, the next process would be me overlaying the swath damage zone onto the county appraiser or county assessor's data and actually get estimated property values of anything that falls inside this zone. All right. And so I was able to overnight, before the governor and the county commissioner showed up in the office the next morning, produced over 300 maps, plus I had dollar amounts of probable damage. All right. Now, why Sedgwick County and Butler County didn't get on the ball and do the same thing, I have no idea. They're no longer in my hands. But hopefully those people did their work and did the same thing to help the recovery efforts in this area. But Landsat and Sentinel data is so useful in natural hazard assessment. Okay. Now, if this storm had hit at a little later time when the trees were fully bloomed out or leafed out and there were crops in the field, other band combinations could have told this story a lot better. All right, so let's turn off May 9th. No, let's leave May 9th on. And let's bring up this Sentinel bottom of atmosphere reflectance 10-meter resolution data. And notice that things are red now. All right, because I have mapped the near infrared to the red channel, the red light, visible light, mapped to the green channel, and the green visible light mapped to the blue channel. This is known as false color image. All right. We are showing infrared data, and infrared is really useful for doing crop health assessment. So here you have nice dark pink. Okay, this is a golf course. All right, nice manicured, watered, fertilized ground, so it shows up really nice and healthy. These darker reds are broadleaf trees. And here on the ground in this piece of agricultural land, the crop, most likely this being Kansas, is probably wheat or soybeans, but most likely winter wheat, where it's green, nice and green, okay? But it shows up red in infrared, okay? If the crop was unhealthy or damaged, it would be more of the brownish tan color, okay? But since this is early in the spring, the crops haven't had really a good chance to really get nice and healthy and big broad leaves and stuff. So it's a little harder to use the infrared at this time of the year. But if these trees were all full in bloom with leaves and there was nice crops on the ground, that tornado would have changed this reflectivity of the crops or the vegetation even more visible. So we use different band combinations based on what we're looking at, okay, or what time of the year that we're looking at. So I would use this band combination during the growing season. Let's look at another band combination. And here I've taken the shortwave radiation and mapped it to the red channel. I've taken the near infrared and mapped that to the green. And I've taken the blue channel and just left it on the blue band and left it on the blue channel. But what you see is a little different subtleness. Notice right here there's a ghost image of, looks kind of like a white mist. And the same down in this area. Based on the shortwave infrared and the long and the near infrared, that since I can't use the tree leaves, I can use other indicators that those bands will reflect. And I can see that there are disturbances on the ground in this area based on that, just that subtle haziness of the image, okay? So that helped verify that I was in the right location when I was drawing my damage swath, okay? I would really like to see this area under Landsat, because I can even use the thermal image to get even more information about what's going on the ground, all right? But satellite imagery is extremely important in natural hazard assessment, and that's what I do, other than doing Blender and Microsoft Flight Simulator scenery. So this was just a little teaser on using Geographic Information System for doing damage assessment, and this is a real world situation. The tornado hit April 9th of this year. It was on the ground for about 12 miles. Did extensive damage through the town of Andover just a few days after the anniversary of their 1991 tornado. Poor Andover. You know, you guys hate to see this happen to you. Okay? So that is using GIS and Landsat and Sentinel imagery to do natural hazard assessment. So hey, I have more science videos on this channel. I also have using Blender and making Microsoft Flight Simulator scenery stuff. I want to try to get something for everybody. So hey, if you please subscribe to the channel. I'm closing in on 1,000 subscribers, which is pretty cool. I'm about 47 away. Please subscribe. Hit the notification bells for more videos. And if you incline to support me, buymeacoffee.com/myphysicalworld. Hope you like what I showed you today, and I will see you guys on the next video. See you later.